Hello, in this video we're going to look at the topic of alkenes. So we've looked at alkanes and now we're going to look at alkenes. So we're going to look at naming alkenes like we did with alkanes, how to draw them, what the general formula is, and isomers. And then we're going to finish again with how to react alkenes. Right, so we need to look at how we name alkenes. In the specification you have to name the first 4 alkenes. And you're looking at this slide thinking, where is 1 carbon? But you can't have an alkene with only 1 carbon. So we start with 2. And the same way we named alkanes, we name them based on the length of the carbon chain. So if you look at this C2H4, there's 2 carbons, therefore it's eth. And it's ethene, 3 carbons, propene, 4 carbons, butene, 5 carbons, pentene. And you may have noticed the ending for all of these is ene or ene, and that's because we're naming alkenes. So alkanes were named ane, alkenes ene. So alkanes would be methane, ethane, propane, butane, and so on. Alkenes, ethene, propene, butene, pentene. Right, the general formula is what all of the alkenes will follow. So it's a sort of an algebraic formula that they will all follow. And if you looked at the molecular formulas on the previous slide, we had C2H4, C3H6, C4H8. They all follow a pattern, and that pattern is CnH2n. And I'll just show you how that works again. So n is the number of carbons. So if we pick 5 carbons, let's do C5H2n, so it's 2 times 5 is 10. So the molecular formula for an alkene with 5 carbons would be C5H10. And if you look back to alkanes, they're CnH2n plus 2. Alkenes have less hydrogens, so C5H10 because it's CnH2n. Probably helpful at this point to draw out an alkene, and I'm going to use propene as my example. So remember, propene has 3 carbons and therefore 6 hydrogens because it's CnH2n. I'm going to draw that C. So I'm going to draw my 3 carbons together. And this time, because it's an alkene, alkenes are different from alkanes because they have a double bond. So rather than just 1 line between a carbon, I need 2 lines. So that's what we call a double bond. And if you think back, carbon can only ever form 4 bonds. So now this first carbon has 2 bonds. I need 2 more bonds to add to it. And that's where we put the hydrogens. So always join the carbons and then add hydrogens where you need extra bonds. So let's look at the middle carbon. 2 bonds here and another bond there. So it just needs 1 more hydrogen. And on the last one, it's already got 1 bond on its left, so it needs 3 more bonds. 1, 2, 3. Count up, I've got 3 carbons and 6 hydrogens, and if you look at every single carbon, there will only ever be a maximum of 4 lines going through it. So the double bond is these 2 lines, counts as 2 bonds. Another thing just to make a note of is that we only ever draw 1 double bond in our alkene structure. There can be multiples, but at GCSE just stick to doing 1 double bond. Right, now we know how to draw alkenes, and we can look at isomers of alkenes. And an isomer, if you just remember, is the same molecular formula, but a different displayed or structural formula. And I'm going to use butene as my example here. So butene is C4H8. Right, so let's draw butene. It's 1, 2, 3, 4. And I'm going to put a double bond here. And then I'm going to add the right numbers of hydrogens. Remember, maximum of 4 bonds. 1, 2, 3, 4. This one's already got 3 bonds, so 1 more. This one's got 2 bonds, so we'll add 2 more hydrogens. And the last one has got only 1 bond, so we need to add 3 hydrogens. Right, something that's particular to alkenes is that because it has a double bond between 2 of the carbons, we can actually move that double bond, and that will be a different displayed or structural formula. So I'm going to move along, show you another one. 1, 2, 3, 4. And this time, instead of doing the double bond on the far left, I'm going to do it in the middle. And that changes our structure. So if we go along and add the hydrogens, got 1, 2, 3 here. I need to add one more into this bond, and I need to add one more onto that carbon, and then the one on the end needs another 3 hydrogens. Be very careful, particularly with the middle carbons, that you only ever draw 4 bonds coming out of it, and you count up the bonds, or count up the numbers of atoms rather, 4 carbons, and you'll see that you have 8 hydrogens. You can't have more than 8 hydrogens in your molecule. And these are 2 different isomers. And something you also need to know about the naming, they're both called butene, but we need to be a little bit more specific than that. Because on the far left one, the double bond is between the first and the second carbon, we call this but, we do a dash, 1 dash ene. And then on the second one, we number the carbons, 1, 2, 3. Because the double bond is between the second and third carbons, we'll do but 2 ene. And you should always name alkenes like this, with the number where the double bond is. And just to point out, some of you might think about this. Let's put the double bond on the end. Is that any different from the first one? And it's not. So that would also be called but 1 ene, because we can start numbering from this end rather than the other end. So remember, these are 3D objects. They can be rotated in space. So that's still but 1 ene. Right. When we looked at alkanes, we said they were saturated. And if you remember back, saturated means they only contain single bonds between carbon atoms, whereas alkene is unsaturated because it has at least 1 double bond. You can have lots and lots of double bonds, but we tend to only draw 1 at GCSE. So saturated, only single carbon-carbon bonds. Unsaturated has at least 1 double bond between carbon atoms. Right, the final thing we really need to do is look at the reactions with alkenes and halogens. And the halogens, remember, are the elements in group 7. And particularly, we really look at chlorine and bromine. So I'm going to draw ethene, so that's C2H4. So remember, double bond because it's an alkene. Add the right number of hydrogens. Carbon can only ever form 4 bonds, so there should only be 4 lines around each carbon. Right, I'm going to add, so I'm going to react with let's do chlorine, and chlorine is Cl2. Halogens are always diatomic, so there's 2 atoms in a molecule. React. Right, unlike the alkanes, which needed UV light to react, alkenes are quite reactive. The double bond makes them very reactive. So this will happen in a normal laboratory, it happens at room temperature. And what tends to happen is that double bond breaks. So we're left with just a single bond between carbons. I'm just going to draw what we had originally. So we have carbon, 2 hydrogens, and carbon, 2 hydrogens. Right, remember, carbon has to have 4 bonds. We've broken the double bond, so therefore I'm going to put a bond on here, because that needs an extra bond, and I'm going to put a bond on this side. And what's attached to that bond? If we've reacted with chlorine, put Cl there, and a Cl there. So the Cl will get added on wherever the double bond was broken, and you need to add on a bond either side of the double bond. So it's now got 4 bonds, but instead of having a hydrogen, like an alkane, it's got 2 chlorine atoms on there. And it could be bromine either. So chlorine or bromine would work in exactly the same way. Right. Unlike alkanes, there was nothing else formed. It's just this one product. And this time, all we've done is added it onto the molecule. So quite helpfully, this is an addition reaction. It's called an addition reaction. They'll ask you, what type of reaction is this? It's addition. Right, sometimes you're going to get asked what's the difference between an alkane and an alkene. And you should know that alkanes have single carbon-carbon bonds, alkenes have double carbon-carbon bonds. So that's quite straightforward if you're given a drawing of alkanes and alkenes. But if I handed you a sample of an alkane and an alkene, how would you practically tell the difference? And the way to do it is to use the reaction that we've just done, but this time use bromine water. So that's just bromine dissolved in water, or I could say Br2. So it's bromine water, Br2. And if you look back at the previous slide, you realize that alkenes react easily with halogens or bromine. Alkanes do not react easily. They have to have UV light. So what we would do is we'd react an alkene with bromine water. And bromine water is orange or brown. So it's orange or brown. So when you start, you add your orange bromine water to your sample of your alkane, or you add it to your sample of your alkene. The alkane won't react. As long as there's no UV light there, it's not going to react. And therefore, your bromine water is just going to stay orange. Whereas your alkene, much more reactive, your solution is going to go from orange to colourless. Very important that you write colourless. And the reason for that is because the bromine has been added on to the alkene, which changes the colour of the solution. So alkanes stay orange, alkenes go from orange to colourless. That's pretty much it for alkenes.